This is a router. By the time we're done here, we will understand the primary purpose and functions of a router. And a router is not as easy to understand as a switch, because a switch just makes sense. You want to have devices connected together, you bring out this magical device, plug them all in, and bada bing, communication happens. It learns the MAC addresses, starts forwarding traffic to all the individual ports. That's fantastic. So what's a router do? Well, maybe a way to kind of step into that question is to ask almost a related question. If the switch is so effective, why don't we just connect the world with switches? I mean, why don't we just plug a switch in our house and then have that cable going out to our ISP, Internet Service Provider, or for that matter, our neighbor and their neighbor and whoever else, and just plug it all together and make one big magical network where everything can communicate with everything? Well, technically, it actually would work for a little while, but it would eventually reach a saturation point for two reasons. One, the switch's domain is a domain of MAC addresses or layer 2 addresses. There's only so many addresses that little switch can remember before its memory is full and poof, it explodes, right? It's not able to memorize anymore. But more importantly, the switch has to deal with a very special traffic type known as a broadcast. Broadcasts are necessary network communication because they help all the devices figure out where resources are. However, those broadcasts would eventually become overwhelming, and just the sheer amount of traffic the switch would have to deal with would cause it to also explode, not just learning all the MAC addresses. And I'm not even getting into all the sub-issues that, if you will, of like security. Wow, my neighbor can get into my stuff without any kind of wall between them. That's a little weird, right? So instead, we use a router whose primary function is to control those broadcasts and forward directed data packets between networks. Now, if you look at that, it kind of feels like a contradiction. I'm saying, well, it stops certain types of traffic and yet allows certain other types of traffic to move on. Probably the best way I could explain it is to take you to the chalkboard, right? When you set up a network in your house, it always starts with a switch, or maybe even a switch with a wireless access point attached, which allows the devices, whether they're wired, let's just say that's computer A, or wireless, let's just say over here we have laptop B, if you will, to communicate in and speak to each other. And they can do all of that pretty much without intervention of a network administrator, right? The router, on the other hand, takes some configuration. And the whole reason we would introduce that router is because we want to get outside of our house. We want to get outside of our own network and reach another network. And therein lies the whole deep meaning of the internet. What is the internet? It's a network of networks. It all started with a few schools that wanted to communicate together. They set up network connections, and then before long, other schools wanted to talk to them, and we started this big thing called ARPANETs, networks wanting to talk to other networks. And as soon as somebody started selling something, the story is told. Everybody's jumping on the internet. We all want to buy, marketers, et cetera, et cetera, et cetera. So really, a router just connects you to another network. Now, in our neatly packaged world of today, we would call that an internet service provider network, because those internet service providers take all of their customers and connect them together. And keep in mind, some of those customers are other internet service providers and all of their customers and their customers and then the customers, just customers all over the place. You get the idea, right? It's a network of networks. So the question is, how does your router get you connected to that world and yet still control your traffic inside? Well, to answer that question, it all comes back to the almighty packet. I brought this guy out in the earlier switch video when I was talking about how a switch communicates. A switch looks only at what's known as the layer 2 address, which is the MAC address. So if laptop A wanted to communicate, laptop B wanted to communicate with computer A right here, it could put its source MAC address right here, destination MAC address here, and right through the switch, that communication would happen, no problem at all. When it comes to the computer trying to communicate with the internet website, there's some pretty cool stuff that's necessary. Oh man, I gotta prevent myself from going too far with this because I'm gonna wrap it all together later. So you might see some of this twice in this skill, but check it out. Let's just say we've got a website out here. We'll say it's cbtnuggets.com. And computer A wants to go to that website to get some of the most greatest training in the world, right? So he goes to his web browser and puts in cbtnuggets.com, and that would be you, the user that would be using the computer, right? The very first thing that computer does is do something called a DNS lookup. That means the computer tries to figure out what is the IP address of cbtnuggets.com, and if everything's set up right, it will. It finds out CBT Nuggets is actually 1.1.1.1, let's just say is its IP address. And this computer right here happens to be, let's just say 10.1.1.1. And then something really cool happens that I'm going to say really slowly because I want to make sure that you guys catch it. This is where the layer 3 address comes into play. So watch this, watch this. Let's say that this computer right here wants to download the CBT Nuggets website. The data that it would send is actually something known as an HTTP GET request, which pretty much everybody sends when they go to the internet. They're like, give me what you have, or consumers, right? Give it to me. So we go to, we type in CBT Nuggets, DNS does this thing. The computer says, okay, my data, my message is going to be GET, and what I'm going to send it to is the destination IP of what? What do you think it'll put there? Well, that should be pretty easy, right? 1.1.1.1. The source IP address is going to be me. 10.1.1.1, right? So we filled in the source and destination, but we still have this layer 2 address, because here's the problem. If the computer sends it into the switch and there's no layer 2 address, then the switch won't know what to do with it, because the switch can only see the MAC address. It can only see the layer 2 addresses. Now, I know some of you might be wondering, well, why do we have the 2 addresses? It seems kind of redundant, right? Oh, watch this, watch this. The computer realizes that the switch can get it to things on its local network, not the internet. That's the job of the router. But the computer has to do some directing, because it can't just like throw that GET message out there like, go data, go find CBT Nuggets, go, be free. No. The computer knows that it has to get that to the router. Let's just say, for the sake of this example, the router's IP address is 10.1.1.2. Well, it can't put that as the destination IP address, right? Because if it does, it would get to the router and the router would go, yes, how can I help you? It needs to have CBT Nuggets as the destination. So the question, I know this sounds almost too basic, but it's hugely valid. How does the computer get it to the router and then tell the router that it's not really meant to go to him, it's meant to go through him to the CBT Nuggets world? Well, we've just unpacked why every single network communication has 2 addresses. The layer 2 address lets you get to stuff on your local network, whereas the layer 3 address lets you get to stuff off of the network. There's more to it than that, but I'm going to use that as kind of a blanket rule for the time being, right? So the computer will put the destination MAC address of, some of you might have guessed it, the router. Its source MAC address will still be itself. When I didn't even put the MAC addresses in this picture, that's the job of the switch, right? The switch is figuring out how to get to all those different MAC addresses. It'll get it to the router. The router goes, oh, great, it's for me. Destination MAC address, that's me. And then it'll realize, well, it's actually not for me, because the destination IP address goes to the internet. And that is what the router does, is rely on an IP-based routing table to figure out where all these IP addresses are in the world. It's the one that's smart enough to get you out to the internet or whatever destinations you want to get to, because it has the roadmap. So I know that primary definition right at the top of the slide might have felt a little bit sterile, but now let me read it again now that I've unpacked that for you. A router controls broadcasts, meaning stops traffic that doesn't belong leaving your network, and yet forwards directed data packets between networks. Hopefully that makes a little sense. I want to mention that third bullet. Let me grab my router again. This router is often called a gateway. A router moves data between networks. A gateway moves data between network types. Take a look right here, and I know you can't see it, it's too small. These are actually phone ports, like RJ11, like old analog phone lines, because this is actually a voice gateway as well as being a router, and it's really heavy. The reason it has those is because we can actually use it to convert from the legacy voice world, in that router's case, into the voice over IP world, meaning phone systems running over data networks, and that router can do it all. That's what I mean when I say it can be a gateway between network types. And mind you, the voice network is just one network type. There's many different network types that the router/gateway can convert back and forth as you move data between them. Well, you now understand the primary purpose and functions of a router. I hope this has been informative for you, and I'd like to thank you for viewing.